All right, so for this video, I'm going to go through all of the questions on this worksheet that you see here, the homework set 1. I'm going to go through the question number 3 that was on your lesson 12 worksheet, and then I will go through one or two of the composite figure ones in case you want to get some more extra help on that. And then I'm going to just also draw a couple problems and go through. So remember, this isn't mandatory to watch, but you can skip around this video and you can get to any question you want to do. You can just go ahead and watch. All right, so for this first one, it says, if a given rectangular prism has a volume of 24 feet cubed, what would the new volume be if we double one of the dimensions of the original rectangular prism? So one of the things we talked about in class is that if we're only doubling or changing one dimension, then that means that our volume will change by that exact same rate. And let's just go and show you an example real quick. So if I were to draw this figure for you, and I tell you that we have side lengths of 1, 3, and 8. All right, we would multiply this together and we would get that our volume is equal to 24 feet cubed because 1 times 3 times 8. Now, let's say I go ahead and I double this. And instead of this being a 3, I'm going to change this to a 6. So I doubled one dimension. Well, now we would have that our volume is equal to 1 times 6 times 8, which gives us a volume of 48 feet cubed. So we know that this answer is going to be 48 feet cubed. Well, when we look at the original answer, 24 feet cubed, and our last answer now, 48 feet cubed, all it was doubled. So when you get one dimension to change, you can take your original volume, which in this case it was 24 feet cubed, and you can then multiply it by the exact same rate, so 2, and that means that our new volume will be 48 feet cubed. So you do not have to draw this image that I drew here. You just have to think about, are we changing one or are we changing all? So for question number 2, if a given volume rectangular prism has a volume of 108 feet cubed, what would the new volume be if we half one of the dimensions? Once again, we are only changing one dimension. And what are we doing to it? We're halving it. So that means we are multiplying it by half. So we times this by 1/2, which is then equal to 108 divided by 2, which is then equal to 54. So we can then say that the volume of the new figure after we half one dimension will be 54 feet cubed. All right? We don't have to draw the image like we did in the one before, because when we change one dimension, the volume will change by that exact same rate. All right, so for question number 3, it says what would happen, if a given rectangular prism has a volume 100 feet cubed, what would the new volume be if we quadruple one of the dimensions of the original rectangular prism? So we're only changing one dimension, and we're changing it by quadruple. And quadruple means by 4. So that means we take the original volume 100, we multiply it by 4, and that gives us what the new volume would be after we quadruple one of the dimensions. So it would be 400 feet cubed. For question number 4, if a given rectangular prism has a volume of 10 feet cubed, what would the new volume be if we double all, now this is a key thing, all of the dimensions of the original rectangular prism? All right, so let's go ahead and draw this one again, just to kind of go through an example of what we were talking about in class. So if we're doubling, let's say that we have sides of 1, 2, and 5. So if we were solving for this volume, 1 times 2 times 5 will give me 10. So that means we have a volume of 10 feet cubed, which is what this problem says. So this is an example of what we could have with our shape. Now it's saying that we're doubling all of them. So this becomes 10, this becomes 4, and this becomes 2. So our new volume would be 2 times 4 times 10, which our new volume would then be 80 feet cubed. Now, rather than having to draw this image out and to waste our time really by doing that, what we can do is think about, well, what do we do to all these sides? We multiplied every single side by 2. So what change did we make? Well, we did 2 times 2 times 2, which means our volume is going to change by a rate of 8. Or we take our change in rate, so we're doubling it, we raise it to the third power because we're changing all of our dimensions. And how many dimensions do we have? Well, we have 3 of them. And then we multiply that out, so this becomes 2 times 2 times 2, which is equal to 8. And now that is the number that we multiply our original volume with. So we could have did 10 times 8, which is equal to 80. So the new figure would have a volume of 80 feet cubed, which is exactly what we did when we redrew it. All right, so let's go ahead and do this last problem, number 5. So the first thing is, how many dimensions are we changing? All of them. So that means I need to find my rate, and I need to raise it to the third power. Well, what is my rate? Well, we are halving all of them. So that means I am changing all of these sides by 1/2. And this is equal to 1/2 times 1/2 times 1/2. And 2 times 2 times 2 is 8. 1 times 1 times 1 is 1. So that means our volume overall is going to change by a rate of 1/8. So I will take my original volume, which is this 800 feet cubed, and I will now multiply it by 1/8. This will give me 800 over 8, or 100. So then my volume of my new figure will be 100 feet cubed. All right, so if you really wanted to, you could draw out the image like I did on the first part of both questions. And you could do it that way. I'd still give you full credit for that, but you're just wasting your time if you do it that way. All right, let's move on to the next set of questions. All right, now this question is almost identical to the one that I had you hand in class the other day and that we went over on the do now. So if you weren't sure how to do this, you really should have had the work on your do now written out, and then this way you can refer back to it since it's the same thing. Just ask yourself, well, what do we do in that problem? What do we do here? All right, but what we can do first is let's go ahead and let's just draw this image. So here I'm going to draw a 3D image. Sometimes it can be difficult for me to write on this pad, so just bear with me while I'm doing this, please. All right, so let's fill in what we know first. We know that the width is 3. So that's the only thing that they give us flat out. Because when we look at the rest, it says the length is 3.5 times the width, and the height is 1/4 of the width. So when I want to find out what my length is equal to, I need to do 3 1/2 times 3, because it is 3.5 times as long as the width. So I'm going to change this to an improper fraction by multiplying and adding. So then my length is equal to 7/2 times 3, or my length is equal to 21/2. Based on the way that they wrote this, the width will go here. The length will be, it doesn't really matter. It's all interchangeable. Let's keep it back to what we had to begin with. So width is 3. My length is 21/2. And then it goes and says that the height is 1/4 of the width. So then for my height, it's going to be equal to 1/4, not 1/2, 1/4 of my width. So that means 1/4 times 3. So my height is equal to 3/4. And now once I did this, I have all 3 dimensions. So I can go ahead and multiply these together. So my volume is equal to 3 times 21/2 times 3/4. I'm going to move this down, so the question is now going to be off the screen. And when we do this, we put this over top of 1. So it becomes 3/1 times 21/2 times 3/4. Check and see, can we reduce anything? No, we can't, because all these numbers here are odd, and 2 and 4 does not have any odd factors. So now we're just going to go ahead and multiply across. So I'm just going to do 21 times 3 first, and that will give me 63. And then I need to just go ahead and multiply it one more time by 3. and that will give me 189. So this is equal to 189, and 1 times 2 times 4 is equal to 8. And now, since it didn't reduce in the beginning, it cannot reduce at the end. So our answer, or volume, will be equal to 189 over 8 centimeters cubed. All right, now we're going to go ahead and move on to the composite volume worksheet. Okay, we did, I told you to refer to this as 1, 2, 3, 4, 5, and 6. We did 1 and 2 in class, so I'm not going to do those. I'm just going to go ahead and do numbers 3 and 4. Right? I'll do numbers 3 and 4. So remember, what we have to do is look and see, well, how are we going to cut this? I'm going to cut right here and create these two shapes. I'm going to show you 2 ways you can do it, because if you struggle with drawing these images, then one way you can do it is just cross out the numbers that we don't know. Like highlight, take a pencil and just highlight our sides in one color, and then fill in the sides that we do know here. All right, so we know that this is 8, so this one works. This is 4, this is work. So the last one that we need is this distance here. Well, if the whole thing was 9 and this portion is 5, that means 9 minus 5 is equal to 4. That means that this piece had to be 4. So go ahead and cross out that 9, right? Because you know that we don't use that anymore. So go ahead and cross out that 9. Right, so now we have these sides of, and use a highlighter if you need to, of 4, of 8, and of 4. Now, why aren't I using this 7? If I were going to try, and why wouldn't I use a 7? And it's because a 7 did not go to the very end back here. The 7 was just this little top part of the L. So then the volume will be equal to 4 times 8 times 4. So volume is equal to 16 times 8, or volume is equal to 128. All right, and now I'm going to draw this in a different color. So I'm just going to trace it. So if you have trouble with drawing it, just go ahead and trace it using one of the color pencils that is available to you for any assessment. So we have 5 here, so I know I don't need to worry about solving for this end part because I know it's already 5. So now I need to do is find out this width here. All right, let me just highlight it in black so you know which one I'm talking about here. Well, the way that we do that is we know that the full distance from here to here is 8, and from this front part to here was 7. That means that this remaining piece had to be 1. So now the last thing that we need to do is just figure out the height. We just need to figure out how tall it is. Well, that never changed. It was completely flat the entire time. So that is the same distance that is here, so that means that is also 4. So now we can just go ahead and we can find this volume. So the volume of the blue side will be equal to 5 times 4 times 1, or 20. And just like with composite area, if we want to find the volume of these two shapes, we just need to add them together. So 128 plus 20. So that means our volume of the entire shape is 148 centimeters cubed. And remember, a question like this is going to just be your extension. This would be considered the hardest question of your assessment, and it's something that it's more so like an extra credit question for right now. So if you're not sure how to do it, we'll have plenty of time to work on this again until the next assessment, but it is something that will be expected that you can do by the time that we finish this unit. All right, I'm going to pause this video and I'm going to erase all the work here and here as well, so that way I can do this number 4 off to the side. All right, now the other way that you can do this, and I actually think this is a better way, but if you struggle with drawing them, then it's fine. Just do what I showed you last one, is think about how you would cut these. So I'm going to cut it this way, and I'm going to actually redraw it now. So I will redraw, and remember, all it is you're, whatever shape you're creating for your front, you're just trying to make the exact same shape in the back, and then you just connect all these corners. You don't have to do the dotted lines like I did, but it could be helpful for you. Right now, I'm just going to fill in all the sides that I know. Well, this here represents the height, and I see that it's 7, so I know I can fill that in very easily. this here represents the width, and that's 3 the entire time. That never changes. And then the last one that I would need is the depth of this right here. And that's this piece. Now this whole thing says 5, but our black box only went from here to here. So we know that we're not going to use this number as our answer. When I look up here, this says 4, so that is the value that we will use. It's saying where exactly we went. So we would then just put 4 here or 4 down here. It doesn't matter where you write it. Define this volume. Volume is then equal to 4 times 7 times 3, or volume is then equal to 28 times 3, or volume is then equal to 84. Right? Then I'm going to draw this shape out. The one that we cut off, I'm now going to draw this out front. So let me just get rid of that green line. And once again, all it is just making 2 shapes that you're trying to make identical, where they overlap, one's in the middle, and then you just connect all of your corners. And now this here is this, and that never changed through the entire shape, so that's still going to be 3. They tell us flat out that this is equal to 6, so I know the height of it is 6. And then the last thing I need to do is figure out this depth, right? How deep is it? What about here? Well, this is where this 5 comes into play, because the entire piece is 5, and we know that from here to here was 4, so what is missing? What is left over from this remaining part? And it's simple, 5 minus 4, and that gives us 1. So now to find this volume, we do 6 times 3 times 1, and volume is then equal to 18. We would add the 84 and the 18 together, just like we did with our composite area figures. And that will then give me 102. Why did I just write 8? 102. So our volume is then equal to 102 centimeters cubed. All right, so that is all of the questions I'm going to go through as far as the homework that was assigned. I am going to just create one question for you now. So if you want to watch this last part, maybe when you see the question get written, pause it and see if you can do it first and skip to the end, or I'll write the answer in the corner next to it. So skip to the end if you need help, and make sure that you can do this problem as well. All right, so now what we can do is a company is shipping toy boxes that are cube shaped with side lengths of 1/4 inch. How many toy boxes could the company ship if they're shipping them in the box drawn below? All right, let me just change that. Or I guess I can't. Okay, in the box shape below. So pause this, see if you can get an answer. And I'm going to write the answer in the top right corner now. And after you pause it and work this out, if your answer does not match, then just please make sure you watch this question. If it does match, then you don't have to waste your time with this. All right, so the answer for this will be they can fit 400 toy boxes inside. That's how many they will ship. All right, so the way that I suggest that you do this is you always look at each of your sides, and instead of them written in inches, let's look at them in terms of how many boxes we can fit. So if we have 2.5 inches here, and each box is 1/4 of an inch, we can do 2.5 divided by 1/4, because anytime we're trying to see how many make up this part, we can use division. So then what we would do is rewrite this as an improper fraction. So this is 5/2 divided by 1/4, 5/2 times 4, and then 5 times 4 gives me 20/2, which is 10. So instead of looking at this as inches, I'm looking at it as how many boxes I can fit. And I can fit 10 boxes. All right, then we will look and see, well, how many 1/4 inch boxes can we fit in our depth? So same thing, we take this side, what's the length of it, 2, and we divide it by 1/4. So this becomes 2 times 4, or 8. So instead of thinking about it as 2 inches, we can fit 8 boxes. And that just makes sense. I'm going to go through this one. If we have 1 inch, and we zoom into this 1 inch, and we're asking how many boxes we can fit in that 1 inch, well, all these boxes are 1/4. So that means that we will be able to fit 4 boxes within this 1 inch, because each box is 1/4 inch. there's 4 1/4 inches and 1 inch. But now we have 2 of them, so that means we would have 4 more boxes next to it, or 8 in total. And then the last one is this height. So how many can we fit in the height of the box? So same thing. We do the distance or the length of that side, and we divide it by 1/4 because that's how many, or that's how long each box is, and that will tell us how many can actually fit in that total part. Well, we need to rewrite this as an improper fraction. So 5/4 divided by 1/4. 5/4 times 4, and it becomes 20/4, which is 5. So we can then stack 5 boxes on top of each other. So now we took it out of our dimensions as far as inches, and we're looking at how many we can actually fit going along each side. So then to figure out how many total boxes we can fit is we need to take all 3 of these numbers and we need to multiply them. So 5 times 8 times 10, 40 times 10, or 400. So that means we can fit 400 toy boxes inside this shipping box. All right, so that is all I am going to go through on this video. If you have any questions with anything, please reach out on Remind.